Hi, I'm Michael Goddard. This is a quick demonstration of my senior design project. There is a more detailed explanation of how the project works in the email I sent Mohit, and the code is available up on GitHub. So what my project is an educational tool for new programming students to learn the fundamentals of programming, such as variable assignments, arrays, loops, and functions. My project seeks to help students learn these materials by giving them a controlled environment which they can practice them at their own pace. So how it works is my project randomly and dynamically generates exercises for them to complete. These exercises are designed to test the students' understanding of the programmatic flow of logic, and so they can actually try and understand what code is actually doing instead of being caught up in syntax and typing problems that new students are often get frustrated with. The project is using a pseudocode like custom built language that I've built that is very simple and should be easy to use and easy to learn for all students, no matter what language their primary instruction is in. And you can see an example of that actually right on the screen right now. Because on the screen here, I have generated a conditional problem. And conditional problems are actually the third topic covered after variables and arrays. Those are very simple, so I figured I'd skip something more interesting. So you can see here on the screen the function, the class rather, that has been generated. So we have a class, clue, and within that a function, just main, a variable assignment, an arithmetic operation, an if statement, an else component, if component, and else component, within each component, and arithmetic operation. Then a return statement. So each line has been randomly generated so that the variable and the value names and the arithmetic being done and the conditional statement is all random, as you will see at the generate more problems. You will probably be able to figure this one out, but if not, I'll give you a hint that the answer is always A, at least for the development system. So I'm going to go ahead and put in a correct answer here, A, and we'll get correct result and a new problem generated. So these problems, as you may notice, are quite simple if you actually understand what the program is doing, and you understand how if statements work. And this is by design, just to test the students' basic understanding of these concepts. You may have also noticed that as I put in a correct answer, the difficulty slightly increased, so we get more variables involved and more lines of arithmetic, just to increase the difficulty slightly. So I'm going to go ahead and put in a few more correct answers, and what's going to happen is the level is going to increase, and we're going to reach loop questions. So you can see here the for loop, which is randomly generated. So like the conditional question, it just tests the student's understanding of how the flow for loops fundamentally work. You may also notice, as I put in another correct answer, is that as the difficulty increases, we get more iterations of the loop and more lines of arithmetic. So now I'm going to skip ahead to more interesting problems. Actually, right here is a loop with an array component in the as the limiter factor. You can just ignore this, the red lines. Obviously, this is a work in progress, so I have a few bugs, but it won't affect the generation of problems. So this question tests both loops and arrays and how they interact with each other. So now I'm going to step ahead one more time, and we're going to start seeing nested questions. And these can begin to actually test the student's understanding of programmatic logic. And like the simpler problems have been randomly generated. So how the random generation works is each component is responsible for generating the component beneath it. So at the very top, we have a class component. Class to end class generates the one function that we need for this type of question. Then the function generates the variable declaration in the arithmetic, and the function component will generate the first if statement here, the first if and the first else, and then the conditional component will generate its children, which is the loop and the other conditional, and then these in turn will all have their children, being the arithmetic component here, here, and here. So this is an example of the nested hierarchy system I have for problem generation, which allows for generation of very complex problems, but is still functional and comprehensible. So I'm going to go ahead and generate another problem. And as you can see, as I put in more correct answers and difficulty increases, we get higher nesting level. So there's more possibilities of nesting. Currently, I have the nesting capped at 3. So there can be 3 levels because it gets very complex very quickly. But this is its current state. Okay, so now I'm going to go ahead and skip to functions. So here in functions, we test the student's understanding of function calls and parameters. So I'm going to quickly here jump through them so I think you get an idea of how the problem generation works. You can see it switches from values now to variables to make sure they understand how scope works. Like you can see we have a D in this function and D in that function that are different. And as difficulty further increases, we get more functions being added, like here. Now there's 3 functions, and we start to allow child functions to call the other child functions. And then at the very end, we will have a functions being allowed to call themselves here. So this is in a sense recursion, testing the student's understanding of how recursion works. Alright, now I'll switch gears real quick and show you a different type of question I have, which are fill-in-the-blank questions. Previously we just had multiple choice, but now we have fill-in-the-blank, which further tests the student's understanding. So how it works is that problem or code is generated, and a single part of it is removed, and we ask the student to fill in what belongs there. For the purpose of development, I put the expected answer up top so we can progress quickly through them. So I went ahead and put in 0, the expected answer. What happens is this code will be converted to Java and then compiled and executed, and we see what the function returns. At the -6, that is correct, and a new question is generated. So you can notice here that the question marks are moving, so we can test the student's understanding of each different part of the for loop. So multiple choice questions exist for all of the question types, so I just figured I should show you one so you can get an idea of how those work. So they're pretty much the same for the other types, so instead of removing the loop definition, we'll say remove a function call or remove the conditional statement to make sure the student understands what is happening. So that was a quick run through of my program running. I should state that the final product will be a web application that a student can use online. Obviously, its current state is kind of limited here in Eclipse, but I wanted to do the back-end algorithmic function generation first before I moved on towards the front end. So if you have any questions about how this works, you feel free to email me, and I will do my best to answer them. Any questions you have. Thanks.